Algebra 2, Lesson 11, Understanding Polynomials. I think both Lesson 11 and 12 are fairly short, so we'll try to look at all of this. Hopefully you'll get a good enough handle on it. Lesson 11 here, we start off with talking about monomials. Okay, mono meaning one, right? You've heard the phrase mono y mono, right? What does that mean? One-on-one, right? Okay, mono means one, is a number, a variable, or the product of a number, and one or more variables with whole number exponents. A polynomial is a monomial or sum of monomials. Okay, the terms. Okay, should I pay attention anytime I see a word in bold? Yeah, those are the terms for this lesson, or these are the vocab for this lesson. The terms of a polynomial are its monomials, its single sets. The degree of a monomial is the sum of the exponents of its variable factors. The degree of a polynomial is the degree of its monomial with the greatest degree. Okay, and I know I'm going through that really quick, but there's a chart in here that will kind of explain some of this a little bit. Okay. All right, so let's slide down here a little bit and see what more information we gather. All right, so here we have a monomial. Okay, even though there's a lot of things going on there, there's two variables, there's an exponent and there's a constant, or sorry, a coefficient, it's still a monomial. Okay, 5ab to the third is a monomial. It has a degree of 4 because it has an exponent of 1 plus 3 equals 4, right? A has a variable of 1. So if you need to write this down, you'll see that my degree is the sum of my exponents. Okay? We get that? All right? So it's got a degree of 4. Okay? Actually, I'm sorry. And the degree of a polynomial is the degree of its monomial with the greatest degree. So in this case, because it's a monomial and not a polynomial, our degree is just 4. Here we have down here a polynomial. Okay? This has a degree of 5. Can anybody tell me why it has a degree of 5? No? All right. Go ahead, John. All right, so here we have a monomial, negative x y cubed. What is the degree of that? No? That's 4. Okay, what is the degree of x squared y cubed? 5. What is the degree of negative 3x squared y squared? No? 4. Okay, so the degree of the polynomial is the monomial with the largest degree. The largest degree there is what? 5 from the x squared y cubed, so the polynomial is said to have a degree of 5. Okay? It's not the first one, it's not the last one, it's not the number with the largest coefficient, it's the monomial with the sum of greatest exponents. Okay? So a one-variable polynomial is in standard form when all like terms have been combined, and its terms are in descending order by degree, meaning from greatest to least. So down here, we have a polynomial, and it's in standard form because I'm starting off with a variable with the highest exponent. Then I'm going down. Variable, next highest exponent. Okay? Coefficient, variable, next highest exponent, until I finally get down to a constant. So when something is in standard form, my exponents will have their degrees in descending order from greatest to least. Okay? Just like on a quadratic equation, you see x squared plus or minus something x plus or minus constant, right? All right. A polynomial function is a function in the form of this. Now this looks really complicated, but basically what we're saying is that we're starting from the greatest exponent going down. Okay? Until we get to a constant, which is a to the 0. So n is a non-negative integer, and the coefficients a are real numbers. The leading coefficient is a to the n. That's all it means, is it just means that it's a coefficient. Okay. The constant term is a base 0, and the degree is n. So it's really complicated. I don't like it whenever they do things like that because it's hard to make sense out of. on your own. But here's a really good chart to give you examples. Now, these aren't all of them that there are, but these are basically things that you might see. Polynomials can be classified by degree and by number of terms. So -4 has a degree of 0. Okay? There's no variable with any exponent there. Okay? Essentially what they're saying is, like, let's imagine x is there, but it has an exponent of 0, so the degree is 0, which means anything to the 0 power. Does anybody know what anything to the 0 power is? 1. So what's -4 times 1? -4. So I could just as easily leave it like that, right? So -4 has a variable with a degree of 0, which is why I'm just writing it as -4. Do you follow me? Okay, so it's got a degree of 0. So all we can do is classify it as a constant because there's no variable there. It's just a constant. Okay, it only has one term, right? It's just -4. And because it's one thing, it's a monomial. Do we understand that chain? Okay, here. Okay, this number of terms. How many terms are here? 2. So we're going to call it a binomial. Same way a bicycle has 2 wheels, it's a binomial. Not a two-nomial. Okay, a binomial. Okay, the degree is based upon the variable. What exponent is there above the x that I don't see? 1, which is why it has a degree of 1. Okay, it's a linear. It's linear in that sense. Okay, a variable with 1 as an exponent is linear. There are 2 terms. I've got x and I've got 2 terms, binomial. Okay, next I've got x squared. Now, I mean, I probably could have figured out how to get the 2 above the x, but you guys understand what the caret symbol means when you see it? Okay, good, because that'll help me later, and I won't have to try to figure out how to do all kinds of goofy stuff to get the 2 or the 3 or whatever to show the exponents. So I've got x squared plus x minus 6. So the degree is the variable with the largest exponent. The largest exponent here is 2. Okay? Classified by degrees. This is confusing because normally what do you normally think of when you see the word quad? You think 4, but in math it's 2. 2 exponent. Quadratic is 2. Okay, or at least the exponent is to the second. Okay? In fact, if you look down here to where we see 4 as an exponent, it's called quartic. Okay? So I don't like that, but I didn't write this, okay? That's 4. Quartic is 4. Quintic is 5. And then from there, it probably makes a little bit more sense. You kind of see it match up maybe a little bit more with kind of like the Spanish, right? So you'd get like octic, that type of thing. Okay, kind of like ocho, those types of things. Granted, we don't really ever go that high, but you'll understand it. Okay, so yeah, 3, you would think it would be like tritic or something like that. Or sorry, 2 there, dosic. No, but it's not. Okay. All right, so here we see the degree is 3, but the number of terms goes back down to 1, right? Okay, so they're only doing like 1, 2, 3, 1, 3, 2. Okay, this has 1, 2, down here, just so we're kind of pairing up on the video there. All right, this has 3 terms, 1, 2, 3. But the degree here, the highest one is 4, so it's got a degree of 4. By degrees, we call 4 quartic. Number of terms is 3. We're going to call that a trinomial. Okay? So when we classify something by number of terms, we use that nomial, 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 nomial. Okay? When we classify something by degrees, a lot of times it's ik, 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 ik. Okay? So if I'm using nomial where I should be using something that ends in ik, probably have done something wrong. Okay? So just things to look for because it can be confusing. Because like I said, here this is 3, right? But we're not calling, what else do we think of whenever we think of cubes? What number would you associate with a cube? 4. So you see, yeah, 6 sides, but I mean, cube, you think square, you think 4. So you've got at least 3 terms there that seem to be attached to the number 4, that 2 of them have nothing to do with the number 4, or aren't used for 4. Meaning quad, we think of 4-wheelers, okay? Cubes, 4 sides per side, and quartic, which quartic you don't actually associate, but there it is. So this stuff you may actually have to study, right, and memorize, because it's not natural that your brain will just automatically get that right. Okay, from there we're going to go to this next lesson, lesson 12, which is solving inverse variation problems. We've talked about direct variation, that y equals kx, correct? We've talked about that. Go ahead. Did I not send this?
Yeah, but it says it's not available.
Oh, I may have sent the wrong file. Let me, I'm going to hit pause on the video and get it set up. All right, from here, lesson 12, solving inverse variation. Like I said, you guys have done direct variation. That's that y equals kx. Now we're going to talk about inverse variation. When we're talking about inverse, another word for inverse is reciprocal. Okay? When you think about reciprocal, we typically think about fractions, right? So what's the inverse or the reciprocal of, say, like the number 5? 1/5. Okay? So with direct variation, we had y equals kx, right? With inverse variation, we're going to get y equals k over x. Okay, k stays on the top, x goes to the bottom. That's inverse variation. Okay? Is that a lot different? Well, it does. K does equal yx, because if I had to solve for k, what would I do with x? No. If I was going to solve for k, I would multiply by x on both sides. So yx equals k when we're talking about inverse variation. Over here, if I wanted to solve for k, I needed to divide by x, right? So y over x equaled k. Okay, this is direct. Okay, this is inverse variation. All right, we can see that. All right, so if the product of two variables is a constant, then the equation is an inverse variation. See, that's what we're getting here when we're solving for our constant. If the multiplication of two variables, in this case y and x, equals a constant, then we're inverse. Right? Okay? Both x and y are variables. K is the non-zero constant, just the same way it was during direct variation. Okay, the term k is our constant of variation. Right? That hasn't changed. We learned about direct variation, so basically what we're going to do is we're going to look at the differences between the two. Okay, direct variation. When two things vary directly, as x goes up, so will y. In inverse variation, as x increases, y will decrease. Okay, inverse variation. One goes up, the other goes down. All right, I'm trying to think of things that as one thing goes up, the other goes down. I don't know. Let's talk about video game systems for a second. And time or speed of something. Okay, the newer, or probably let's say the more expensive computer or video game system, what should happen to the time that it takes something to load? Should go down. There should be an inverse variation. The newer, the better, the more expensive, okay, the less time it takes to do what it is that I want to do. Right? Does that help? You don't play video? Sure you don't. Sure you don't. Okay. But I'm trying to think about, other things that have an inverse variation. Yeah, I don't know. I could probably come up with something, but not off the top of my head right here. Indirect variation, as x decreases, y decreases. They both go down together. Okay? I think about, just because I have kids, I think about the cost of clothes. Okay? The smaller the close, typically the price goes down, right? My shoes, as shoe sizes get bigger, as people get older, right? Shoes get more expensive. The price goes up with the size of the thing, right? Okay? But in inverse variation, as x goes down, y goes up. Okay? So inverse. Okay, you'll see them going like that. All right? In direct variation, if we wanted to find a constant, we took y and divided by x. In the inverse variation, we've already seen this. If we want to find a constant, we take y times x. So given a set of coordinates, it's possible to determine if a set of coordinates represents a direct variation or an inverse variation based upon how x and y relate to each other. Okay, I can look at a table of values and see that as the x values increase, what is happening to the y values? Are they also increasing or are they decreasing? So if I'm going, let's see, just over here. If I've got x, y, these are going 1, 2, 3, 4, 5, 6. What's happening to these numbers? They're increasing, right? But if I have 496, 322, 298, 164, okay, 92, 68, right? What's happening to those numbers? They're decreasing, okay? They're decreasing. So would I assume that that's going to be direct variation? No, because in direct variation, as my numbers get bigger, these numbers should get bigger over here, okay? So I would say first, okay, this looks like it might be inverse variation, but do I still need to check? How do I check? I have to find a constant, right? How do I find a constant in inverse variation? No, look at the notes. Don't guess. X times y, right? X times y. So I take 1 times 496. Well, that's going to be 496. Now I got to take 2 times 322. Is that going to be 496? No. Okay, so although it looked like inverse variation, it wasn't actually inverse variation. Okay? So just because one goes up and the other goes down doesn't mean it's automatic, right? I have to check it. Okay? So you want to go back and reread your notes to know how to determine, what do I need to do here? Do I multiply or divide? Because it's not the same. Okay? Joint variation, all right, involves 3 variables. Okay, so if it asks, is this joint variation? I have to have 3 variables. Okay, I've got to have an x, a y, and a z. K is always, all right? So we're not saying that this is 4 variables. It's not. K is a constant. But I've got to have an x, a y, and a z. Okay? One of which depends upon changes in the other 2 variables, meaning z is dependent upon what happens with x and y. Okay? A joint variation can be written like what we see down here. The variables x, y, and z, and k is the non-zero constant of variation. So if we start, they're just going to ask you for the most part, is this joint, is this inverse, is this direct, or is this joint? That's usually the question. If I see a third variable show up, I'm going to say, well, that's got to be joint. Okay? All right, so that's both those lessons. Let's look at solving a couple of questions. What time are you guys out of here? 36, so we're going to answer like one question. Okay. Let's see, we want Algebra 2, lesson 11, 12. All right, do you want to do the lesson 11 question or a lesson 12 question? 12, you want to find a lesson 12 question? Okay. All right, so you want something involving direct or inverse, right? Okay. Determine whether the relationship is an inverse variation. All right, what are happening with the x's? Are they going up or down? They're going, as I go down through the list, am I going up or down? Just because Just because I'm looking at it downwards doesn't mean it's going down, right? It goes 2, 3, 4. So my numbers are going up. Okay? What's happening over here? 409, 240, 194. They're going down. So based upon appearances alone, it looks like in what kind of variation? Inverse. What do I have to do to check? Multiply. 2 times 409 is? Okay. 3 times 240 is? Do I even need to multiply 4 times 194? No, because they're not the same. They're not a constant. So it's not, is it an inverse variation? No. I have to have a constant. It is not any kind of variation without a constant. Okay? Yeah. Okay. So if all of those had been 818, we would have said the product xy is constant, so the relationship is an inverse, and we would have picked C. Okay? But because the product xy is not constant, it's not an inverse variation. Okay? You follow me? So our answer comes out as D here. All right? Let's look at, let's see. I'll try to find another. Let's go down to like number 8. Something where we're looking at the data a little bit differently. The data below represents an inverse variation. Let's find a constant. What do I have to do with my numbers? All right, what's 2 times 84? 168. 4 times 42. What is that?
No, 168.
And 6 times 28?
168.
Okay. So it didn't ask us, is this an inverse variation? But we should still check it all the way through. Okay? So the constant there is 168. Let's see. All right. This is probably a good question to end on if we can get through it. There's a researcher is studying, doing a study known as an inverse relationship between the number of bears and the number of beehives in a certain part of the woods. As bears go up, what happens to beehives? They go down because bears like honey, right? Okay. This varies depending upon what time of year it is. He observes, his observations are as follows. Now, let's be clear here. We need to figure out which is X and which is Y. Okay, what is my input? What's my independent variable? Bears. Bears are X because the number of beehives is dependent upon how many bears there are, right? Okay, more bears, fewer beehives. Fewer bears, more beehives. Okay, so you can go from there and find out what your constant is, right, to get the rest of your information on. Okay, so we should be able to use that to find a constant, and then once we input 24, figure out how many beehives we would have. Okay? All right. Both lessons due tomorrow. I think it's right around 20 questions, but no essay. Okay?